Hi there, everyone. My name is Chris Pont. I am CEO at IJYI. We're a software delivery, data and BI consultancy with clients across various sectors and geographies, from SMEs, councils and building societies, right the way through to global brands. And we talk about software delivery, not just software development, as we work with our clients on the whole end-to-end piece, helping with discovery using our inception workshops, producing business or investment cases, developing and testing software, non-functional testing, automating infrastructure and deployment, and supporting and maintaining the platforms. And that goes for data and business intelligence solutions too. So today I'm going to talk to you about IoT, the Internet of Things. And it's difficult to know where to pitch this really with such a varied audience. So a brief description that I found highlighted at the top of Google when you search for IoT. So the Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. Now that's a pretty rubbish description, really. It doesn't really say what IoT is, and it's not particularly exciting. So I think a better description would be the Internet of Things, or IoT, relates to a world where everyday devices leverage the power of internet connectivity. And that could be devices that collect and send data. For example, a smart doorbell that collects data about when the button has been pushed and uploads a video of whoever is standing at the front door. I mean, I've got a smart cat flap at home. My wife worries when she hasn't seen one of the cats for a day or so. So the cat flap will scan the tracking chip in his neck and push a notification when he's home. And then there's devices that receive commands and action them. So I can lock that cat flap when I know the cat is home, or I have a smart lawnmower that I can either send out when I want to mow the lawn, or I can tell it to go back to its dock if my son's out playing in the garden. Or more likely it is that we have devices that do a bit of both. They collect and send data, and they receive and action data. They action those commands. So why does this matter? Well, this technology unlocks a lot of value across pretty much every sector. For example, better insights. So being able to monitor and collect data to understand behaviors, actions and trends means that we can develop much better products, deploy resources more effectively, and market more effectively. I've got an HP printer at home that knows how much I print, and an HP will ship me ink whenever it's close to running out, so I don't need to think about it. I mean, if I print the complete works of Shakespeare, then they will step me up the pricing tiers and it will get more and more expensive. But it's monitoring how much I'm using the printer, and it's sending me supplies whenever it's appropriate. More maintained equipment, so monitoring the health of industrial equipment, and this is where machine learning would have a role to play, because if we know that once a piece of equipment starts exhibiting certain behaviors, then generally it only has 60 more movements or 500 more miles or 30 more lifts left before it's out of commission, then we can send a maintenance crew out to fix it during expected downtime, rather than having the machine out during production hours. So that could be worth a fortune in certain industries. I mean, my car will report to the manufacturer when it needs a service, and if it breaks down, it will self-diagnose and it will send that data off, so that potentially the breakdown person turning up, he turns up with the right parts. It's much more efficient than sending out the wrong person who doesn't have the ability to actually fix the problem. More effective use of resource, so precision crane movements. One of my colleagues worked out in West Africa at one of the shipping ports, and they stated that if they could get just one additional crane movement per hour, that would be worth over $1 million a year. And it turns out that having huge container ships berthed for any longer than is necessary is a really expensive business. Safer environments, so footfall monitoring, something we're involved in right now, using one of the Raspberry Pi devices, and I'll talk about those in a bit. We're able to work out how many Wi-Fi devices are in a given area. It's an approximation, as some people will have more than one device, or some people won't have any at all, but it allows our client to then deploy safety personnel to the correct areas. as well as work out the routes that people are taking across their properties and improve the overall experience. Then we've got security and asset monitoring. So coming back to shipping and shipping containers, obviously it's useful to track where a container is, but depending on the cargo, there may be environmental concerns. So it might arrive at 2 degrees centigrade, but did it go above 5 degrees centigrade at any point during its journey? Were there any shocks or vibrations? Were the container doors opened at any point? And what were the noise levels like during transit? You know, we can monitor all of that sort of stuff and report back so that we know that any goods that have been delivered haven't been damaged or tarnished during transit. So why are we getting particularly excited for IoT now? You know, a lot of what I've spoken about has been possible for a while. Well, let's talk about a few things that affect the ability for smaller business to make use of this sort of thing and develop or prototype using this technology. So there's the adoption of inexpensive devices. So this here is the Raspberry Pi Zero. It can run a full version of Linux. It's got USB, HDMI, an SD card slot, and the ability to extend using hats. So a GPS or 4G hat is about £60, and that can sit on the top of that device, and it can then give it the ability to not only know where it is, but then transmit that information back over the 4G network so that we can track those devices. And for about £20, you can get a box of about 40 sensors that you can plug into it, including shock sensors, light sensors, temperature sensors, humidity sensors, infrared, etc. And you can deploy to these devices using code such as .NET, C#, Python, Java, embedded C, basically anything that will run on Linux. So we're not limited to embedded code development anymore, which is a little more niche. It's entirely possible that the developer who's been hired to develop a new payment integration for your website would be able to write something to run on one of these devices. We've then got the arrival of 5G. Now, we've been through various upgrades of the mobile networks before, and you know, from 2G to 3G to 4G, and you would have been forgiven for thinking that 5G just means a bit faster, and there that is at the top of the list, higher bandwidth. But enabling the Internet of Things is more than that. So we've got lower latency. Every time your mobile device starts communicating, there's a small delay, and it may only be a few milliseconds, but that could matter with a smart device. The radio technology that makes 5G possible promises much lower latency, meaning that devices have the ability to rely on a quick response. So things like self-driving cars, you know, if you're making decisions in the cloud, then you want that quick response. Got greater reliability. So again, that radio technology has improved the reliability, meaning that once you have a connection, it's much more stable. And then you've got edge compute. So this is the exciting one for me. We'll have the ability using a technology called containerization to deploy software at the mobile base station. So for areas that are dense in a particular type of IoT device, rather than having to connect all the way back to a data center or public cloud, the processing capability is right next to that first hop to the mobile base station. So this further improves the latency, and it can mean that devices can seem much more intelligent, even though that intelligence is built into the mobile network rather than the device itself. And then we've got lower battery consumption. So there's different flavors of 5G, but effectively the radio technology means that we can have a small, very low powered device running on batteries for potentially years. So you could stick this device somewhere where you need to monitor something, and it can just sit there running off its own battery supply for years on end and communicating with the mobile network. And so public cloud now offers a huge array of platform services to support IoT as a commodity service that you're able to just dial up and down as needed. So SMEs can proof of concept IoT ideas with minimal outlay and risk. So services to provision and manage these devices are centrally available. Storage is pretty cheap, meaning that we can collect a huge amount of data and process it effectively to draw insights and make automated decisions. So let's look into some of that right now. So we've got Microsoft Azure IoT Hub. This has the ability to manage and communicate with millions of devices. So this is a service built into the Microsoft Azure Cloud, and it's built to work with these devices. So there's SDKs available for IoT Hub. That means that you can write code for devices in many languages such as C, C#, Node, Python, iOS, Java, and for the actual device SDK, you can use something called embedded C. So the likelihood is that whatever hardware you're working with, you will be able to write code that will interact with the Microsoft Azure IoT Hub. And it's got communication support for a wide variety of communication protocols. Some of those acronyms there might not make a lot of sense to some of you, but it shows the support that the IoT Hub has to communicate over different protocols. It can handle device provisioning. So there's a device provisioning service. And basically, when you're manufacturing these devices, you don't want to be putting credentials to connect to your cloud subscription on those devices. You have a production line that's just banging out these devices in bulk. You don't want to have to put bespoke code on every single device. So we have the device provisioning service, and what that can do is communicate with your Azure IoT Hub and say, I'm definitely a device of a particular manufacturer, so I'm one of your devices, and it can attest that it is in fact one of your devices through a certificate process, and the Azure IoT Hub will check that, make sure it is who it says it is, and it will give it the credentials that it needs to connect to the hub. It supports bidirectional communication, so both device to cloud and cloud to device, so you can communicate both ways. It supports telemetry, so the device can report back exactly what it's doing, any issues that it's had, any problems, anything that can help debug any issues happening with that IoT device. And it supports something called the digital twin. This is a representation of that device in the cloud, so it allows us to basically mirror what the device is doing or mirror its properties. We'll talk about that in a sec. And it's secure by default. It contains something called the Microsoft Defender for IoT, and it will monitor those devices, making sure that the firmware is kept up to date, making sure that it's communicating securely, and making sure that there's no unexpected behavior or any suspicious behavior happening on those devices. And there's a whole dashboard that will show you exactly what's happening and anything that you should be aware of security-wise. And it's supported by an SLA by Microsoft of 99.9%. So they guarantee that uptime, and there are things that you can do to make that a bit more resilient, but that's a pretty good SLA for a cloud platform. So I said we'd talk about something called digital twins. So let's look into that. So a digital twin is a digital representation of an IoT device. So it will mirror any properties or any state of that device in the cloud, so that you can then make decisions on what's happening and push things back to the device for it to accommodate for that. And there's two states there. There's reported state, so the state that the device is saying that it's currently in. So any properties of that device is reported back to the cloud. And something called desired state. So this is anything you've got running in the cloud that's saying this is how I'd like that device to respond. So it can then push that back to the device and say this is the state that I'd like you to be in. So for firmware updates, for example, you can push a desired state that says I'd like you to be at version 2.5. That will get pushed to the device. Obviously, the reported state might still be at 1.8. So the device will receive that desired state. It will know what it needs to do. It will download a new firmware update, install that firmware update, and then once it's rebooted, it will report that back to the cloud that says, okay, I'm now at version 2.5. And it allows you to tag and group devices. So you can tag a digital twin. There might be groups of devices that you want to manage in bulk, and this allows you to tag or group those devices and process them as part of a group. We've then got something called Microsoft Azure IoT Edge, and what this does is it offloads data processing, AI, stream analytics, or device-to-device communication to an edge device. So as part of your IoT deployment, you might not have those devices communicating directly with the cloud. They might connect with a gateway device. And Microsoft supply an SDK to run on those edge devices to help you manage the end devices and report back into the Microsoft IoT Hub. You can install what's called containers on that gateway device, and they can do things like run a database. They can run AI. They can run stream analytics to look at what all of the devices that they're managing are doing, and they can make decisions themselves. So it means you don't have to go right the way back to the cloud to manage groups of devices. So in manufacturing, for example, this might be useful to have an edge device sitting there making quick decisions, processing massive amounts of data, and then just pushing what's necessary back to public cloud. And the IoT Edge runtime supports, as I said, containers, Docker compatible containers for your own code, as well as a whole library, a whole marketplace of containers, both from Microsoft and other third parties that can run on those gateways. And again, there's built-in security for that edge device. So that means that only authorized edge devices can communicate. And again, it's got Microsoft IoT Defender built in, so you're monitoring both the gateway and those end devices, making sure they stay secure and making sure communication is kept secure. So you might be wondering, how much is this sort of thing going to cost? So let's look a bit at the pricing for Microsoft IoT Hub. The great thing here really is that there's different tiers. Basic tier starts at about £7.46 per month. It's incredibly cheap, and that's for up to 400,000 messages a day, and each of those messages can be up to 4 kilobytes each, and you can scale up from that. Basic tier doesn't enable cloud to device messaging, so it's only device to cloud messaging. Doesn't contain a digital twin or IoT Edge, but it's a good starting point if you've just got a group of devices that you want to report their status back to the cloud. We've then got standard tier. Now standard tier is free to start with for 8,000 messages a day, and they're limited to 0.5 kilobyte each. So the free tier is pretty basic, but again, you might want just that basic communication, not many messages being processed per day. That's a good start. And then it starts at £18.63 per month for 400,000 messages a day at 4 kilobytes each. And you can scale that right the way up. So, that's an S1 tier. So that's a provision for a number of messages. You can scale this up to hundreds of millions, or if not billions of messages per day, and you just pay for what you use. The great thing here is that you can scale this down to the free tier if messages are not being sent. So if what you're doing is seasonal, if you're waiting for devices to be adopted, if devices are only used at certain points, then you can scale down to the number of messages that you're processing, and you're only paying for what you're using. So hopefully that's been a good introduction into IoT and the Microsoft IoT Azure platform. Any questions, please feel free to drop us a line. Thank you.